I can talk slowly. Thanks very much for having me. Thanks to the organizers for putting this event together. I was an attendee last year and really enjoyed it. Thanks also for not putting me directly after Andreas. That was very kind of you. I was pretty grumpy about this post-lunch session until I watched the keynote. So my name is Adrian Bailie. I work for Ripple. Ripple is I don't know if we can still call ourselves a startup. It's about a 5-year-old business based out of San Francisco. We have offices in New York City, London, Sydney, and recently in Luxembourg. I work out of Cape Town. I actually work out of the Rise offices. I've seen a few of my fellow Rise people here today. So I'm a remote employee and normally in pluckies and shorts. My wife made me dress up. We've got about 140 people at Ripple these days, and still about 2/3 of those are engineers. So Ripple started out as very much a blockchain engineering company, originally called OpenCoin. The idea for Ripple was actually adopted from a guy called Ryan Fugger. And it's actually it's an interesting concept, which I won't go into in too much detail now, but happy to discuss with anyone after, where you get communities to effectively trade credit with one another. So instead of having money you pass around, you effectively trade IOUs, and it's a system called Hawala. And Ryan's idea was to try and digitize that because it's a system that could be very efficient for exchanging value between people. So what OpenCoin did was they had a group of guys that I think would be classified in the purists camp, Bitcoiners. Our CTO is a guy called Stefan Thomas who wrote Bitcoin.js, who decided they wanted to build kind of an evolution of Bitcoin with a specific focus on implementing this Hawala system. So the Ripple Consensus Ledger, as we call it, is a distributed ledger technology. It has a native currency called XRP. I saw it come up on one of Lou's charts. But it also has a bunch of other layers on top. It has a built-in trading engine. And fundamentally, XRP, the native currency, is used as a bridge between trades in that trading engine and allowing you to issue your own currencies or issue currency and trade with others and so on. So it was sort of a slightly different approach to the pure ledger and currency approach of Bitcoin. Interestingly enough, though, the evolution at Ripple was such that the company is a commercial entity. It wasn't a group of developers. It wasn't a mysterious person who released this technology. It's very similar in many senses that it's an open source bit of code. You can download, you can run a node, you can join the network. The consensus algorithm is different. It doesn't use proof of work. But Ripple is a commercial entity. So Ripple, who funds all of that development today, has taken things in a slightly different direction over time. And Ripple, over the time I've been there, roughly 2 years, has become very focused on a specific mission, and that is cross-border payments. So how can we improve the state of cross-border payments? And there's a number of incentives and motivations behind that. Today, Ripple has a growing customer base of banks, and what's also interesting is if you've tracked Ripple from the early days, you could almost compare everything about Ripple to other altcoins and Bitcoin itself. You could download a wallet, you could go on exchanges, you could do all of that stuff. An interesting thing happened though to Ripple somewhere along the line is regulators took us seriously, and we got slapped on the wrist by the regulator in the US. And as such, had to curtail a lot of that stuff and get really focused on our core customers, which are banks. So Ripple's vision is what we call the Internet of Value. And our strategic decision was that to enable an Internet of Value, we need to go after the people who manage payments and manage money today. So that's about it in terms of Ripple. I'm not going to spend too much time talking about Ripple, the company, or selling you on our technology. If anybody's interested, I'll introduce you to people at Ripple who can do that. I actually work in a team at Ripple who are primarily focused on R&D. And we, for the last 2 years, roughly, have been working on a protocol we call the Interledger protocol. And I'm going to give you a little bit of background on where that comes from and why we're doing it and what we think it says about the direction of payments going forward. And I realize there are pillars and people who can't see me, so I'll start moving a little bit more. The way we see the payments ecosystem today is as a highly fragmented world of different payment networks. And a lot of this speaks to things we've heard earlier on today about, nation states and city states and so on. Well, payments are no different today. You have all of these fragmented payment networks. And the result is that if you have an account on one payment network, it's very difficult to make a payment into another payment network. If I use Venmo, I can't pay someone on TenPay, for example. If I use PayPal, it's very difficult for me to pay somebody on WeChat. All right. For that to happen, each of those entities has to get together and create sort of bilateral agreements and all sorts of things. So it's kind of a generic problem. It's not just a problem of interoperability between blockchains. It's a generic problem. But the question is why is that so difficult? Because today that is not a problem with data. Sure, we've had 20 or so years of evolution of the internet to get us here. But today, if I'm an AfriHost customer, that doesn't affect which other people on the internet I can send data to or receive data from. So that's the fundamental principle behind the Internet of Value. The Internet of Value is Ripple's vision that it should be as easy to move value around the world as it is to move information. So, for those of you who don't know, the Gandalf-looking guy in the picture is Vint Cerf. He invented the internet. We at least invented the protocols that underpin the internet. Now, he's our inspiration, and he and a lot of the work he and his team have done have really underpinned what we've been doing in the R&D team over the last 2 years. It started, not quite 2 years, it started in 2015 around October when we published a white paper on Interledger, but there was probably a good 6 or 7 months of work getting to that point. And really, we were diving into this difference. What is the difference between the movement of data and the movement of money, and how can we adopt principles and architectures from the internet to make money work better? And the trick and the thing that we realized about the internet is that what the internet is all about is internetworking. That is what the internet is. That's what internet means. It's short for internetworking. And internetworking is the interconnection of networks to form a larger network. Pretty simple, right? So we just need a internetworking of payment networks, job done, drop the mic, right? And that's effectively what we've been trying to build. What we've been trying to design is an internetworking protocol for value. Now today, as I said, payment networks are disconnected, and I'm not just talking about banks. I'm not talking about blockchain, mobile money, online wallets. I'm talking about any payment network. And you can think of it in a commercial sense, PayPal, or you can think of it in a domestic sense, the South African national payment system. The reason it's so hard to send money across borders today is because there's a payment network in South Africa and there's a payment network in the UK, for example. So for me to send money to the UK, I have to send money out of the network here and into the network there. And that's where the massive friction is. That's where the cost comes, and that's the major headache. So what we're looking for is internetworking. Internetworking for payments, the ability for a payment to flow through multiple networks, 1, 2, maybe 3, and go from an account in, for example, South Africa at a bank to an account on an Alipay wallet in China. I knew the conversion to PowerPoint would break something. Anyhow, the solution that we came up with was Interledger, and it's a work in progress. I want to stop there and say Interledger is an ongoing project. In fact, more specifically, it's a community group at the World Wide Web Consortium. So W3C is the standards body for the web, started by Tim Berners-Lee. It has a fantastic community group facility where anyone who has ideas about technology that they want to standardize for the internet can get a group together, and the W3C really helps to facilitate that. So as members of the W3C, we decided that was a great forum for us to get people together to talk about this problem, Interledger. And it started with the white paper and formation of the group in October 2015, and we're sitting at, I think, just over 220 contributors now, and members of the group are from all over. Now, the reality is that the actual participants in the group is a much smaller number than that. Most of the members are lurkers. They're watching, they're trying to understand what we're doing. There is a core group of people who are really invested in this in terms of time and energy, and I think we're making great progress. This is a picture from our workshop we had in London last year. Was an awesome workshop. We had, I think I see some people in that picture from WorldPay, Royal Bank of Scotland. We had two cryptocurrency gateways there, Bitstamp and GateHub. And if you go online, you can actually watch a video of them sending a payment between each other using the Interledger protocol. So it's two guys sending a payment where they have an independent market maker in between them providing the liquidity. So someone who holds an account at both exchanges, he provides liquidity for that payment. So back to our inspiration from the internet, and the technical people in the room will recognize this. For the less technical people, don't worry too much. It's effectively illustrating the network stack. It's the stack of protocols that helps us use the internet every day. At the bottom, you've got the network layer. You've got the individual protocols for individual networks. So, in this room, we're all connected to the Wi-Fi. There's a network here. It's a Wi-Fi network. Wi-Fi is the underlying protocol. But the reason that all of us here connected to this Wi-Fi network can, for example, WhatsApp somebody on another network somewhere else is because of that internetworking layer, the internet protocol, IP. And above that, there's a whole bunch of other protocols that do various things, TCP, UDP. They all have different use cases, and that's when you get up to the application layer. Different things for, different protocols for different uses. HTTP is what your browser uses to fetch a web page. SMTP is what is used to send emails around. Right? So once you've got that fundamental internetworking layer, that thing that pulled all the networks together and created the internet, what you build on top of that is like scarily awesome. And that was I think a point made by both Andreas and someone else today about, once you've got this ubiquity of this platform across the world, you go from 6 hours to send an email to swipe. On the Interledger side, we're modeling ourselves exactly on that architecture. So if you think about payment networks today, each payment network has a protocol of sorts. So blockchains all have their protocol, banks have their protocol, mobile money systems have their protocols. And those are sometimes proprietary, sometimes open, but they are primarily responsible for moving money in that network. And what we're focusing on is the piece above, kind of call it an abstraction layer that says, how do we find a standard across all of these different networks that allows us to move value between them? And really there's 5 ingredients. So I'm going to go through those relatively quickly, and I can try and dive into more detail at the end if people are interested in really understanding the fundamentals. But the first ingredient is a connector. So connector can go by many names. Some people will call a connector a liquidity provider, a market maker. Really what a connector is somebody who links 2 ledgers, 2 payment networks. I've got an account in Bitcoin, and I've got an account denominated in Rand. So I've got, let's say on the left, my Bitcoin wallet, left and right. On my left, I've got an account at Standard Bank. On my right, I've got an account on Bitcoin. Now, if somebody else wants to send Bitcoin to somebody else at Standard Bank, I can be the facilitator for that. They can send me some Bitcoin, and in exchange, I do a little EFT to the guy at Standard Bank, and you've completed a transaction. Sounds pretty onerous, and it is, but if you have a standardized protocol for that, then that solves the problem. So your first ingredient is connectors, providing liquidity to exchange currencies, and I want to point out here that it could also be the same currency. So it could be that that intermediary in the middle is moving money between two local banks or two local payment systems denominated in the same currency. That's also a possibility. An important point to make and an important concept to understand is that when we're talking about Interledger and we're talking about all of these roles, we're talking at a very high level of abstraction. We're talking about roles within a network. So it's quite possible that the same entity, the same organization, bank, cryptocurrency network could actually fulfill more than one of these roles. These are conceptual things. A reason why you need connectors and why you need the ability to do these hops is that bilateral connections don't scale. So as I said right at the beginning, we've got all these different payment networks all over the place. And sure, you can go and send an M-Pesa transaction to someone on Bitcoin, or you used to be able to, but I think the regulator got in the way there. But that's a bilateral arrangement that takes time to set up, and it takes a lot of work. But that still only connects two people, and that's not something, another conversion issue. Those two lines should be connecting the dots. Bizarre. Converting from Google Slides to PowerPoint somehow rotates lines. Anyhow, the bilateral connections don't scale very well. If you've got 4 people who all want to connect to each other, sure, that's 8 connections. As soon as you start increasing the number of people you want to connect together, the number of connections just grows exponentially. But networks do scale. And that's why the internet works, right? You don't need to be connected to everybody else on the internet. You only connect to your ISP, and they connect to a couple of other backbones, and so on and so forth. Networks scale, so that if those two entities want to connect to each other, they can connect via and via. And so to make this work, you need to be able to securely do multi-hop transactions. You need to securely be able to pass money through multiple entities. And that is why, just as a slight aside, that's why philosophically, certainly within our team at Ripple, we don't believe that the world's payments will ever be on a single distributed ledger. It's just, conceptually, it's a scaling problem that we'll be constantly trying to solve. And I don't think we don't believe it's the right way to solve this particular solution. The solution to the internet wasn't, okay, everyone get on AOL, or let's all get on CompuServe. So how do we get multi-hop security? Correspondent banking is a good example in today's financial world of how money moves between networks. As I said, you move money from South Africa to the UK. It goes through a few banks, a correspondent bank in the middle. The sad part is if you're moving money from South Africa to pretty much anywhere else in Africa, it goes via Europe or somewhere else and changes into dollars in the middle. So no wonder it's probably the most expensive remittance corridors in the world. But that's effectively how it works. It's a UDP of value movement. Pass the money on and hope for the best. The obvious result, which happens a lot, you'll be surprised, is that payments fail. And when they do, the person at the end who didn't get the money has to go and try and figure out where it failed and track the money down. Now, what Interledger introduces, and incidentally, this is exactly the same concept that's used in Lightning. So you'll see there's 2 references here to how this works, is a preparation phase and an execution phase. So first, payments are prepared between each entity. So each entity who wants to participate in this multi-hop payment has money on hold. It's taken out of the one account, but it's not paid out into the next account. And I think in the final question that was asked earlier about Lightning and Bitcoin, that's the piece that everybody's waiting for on Bitcoin. The ability to create a transaction that will expire and roll the money back or pay it out based on a condition. And that capability is what will really enable Lightning on the Bitcoin network. So within the Interledger protocol, we've effectively spec'd out the same thing at a layer of abstraction higher. It's not specific to Bitcoin. It's kind of saying this same concept can be reapplied across any payment network, any ledger. So the Lightning and Interledger flow is the thing that enables trustless connectors. I'm going to go back a slide, I only have to trust the next guy. I only have to trust that he will follow the rules, and if I don't trust him, then I make sure that the ledger that we share the ledger that my account is on and that his account is on, where I'm transferring money, is a ledger I trust. And in the case of Bitcoin, that's exactly how it would solve the problem. So cryptocurrencies solve that trust problem. They bring the line of trust, or the level of trust required, one step closer to the initiator. The third ingredient, and this is where we diverge from Lightning and other similar projects, is the ledger abstraction. So basically saying, this could work on any payment network. There's a few basic services that underlying payment network needs to provide, but if they don't provide them, there's ways to get around that with a layer of abstraction above. So the basic functions, as I've said, are I need to be able to initiate a transfer on that ledger or on that network, but I need that to be conditional. I need that payment to only work if a specific secret or a specific fulfillment is returned to release the money. And then obviously I need the ability to do that fulfillment. So this is a copy of the JavaScript reference implementation API stuff. It's quite technical, but the concept is there. Effectively, any system that can support what we call conditional payments can become a hop in an interledger payment. Cryptocurrencies perfectly set up for that. This is where things get quite funky. The fourth ingredient is the address and the interledger packet. So how do I send money to an intermediary but tell them that that money is actually destined for the next guy? So how does Alice, in this instance, how does Alice tell Chloe, when I send you these 100 bips, you're only going to get them if you deliver 107 bops to Bob? And that's how that's where we use the address in the packet. So we have a packet that basically holds Bob's address and the amount that Bob must receive, that is sent right from the beginning and passes along the chain. And that's pretty much what it looks like. The address, it looks like a domain name. It's not a domain name. It's actually more like an IP address for accounts. So the address is a universal account addressing scheme. So in this case, that address looks like it's an account assigned to Bob's car at Chase Bank in the US. That address is a Bitcoin wallet. So you can see how it's a hierarchical address, starting from G is the global namespace, C kind of neighborhood, it's crypto or the type, and the previous one it was US dollars. So it's a hierarchy, and that's important for the final ingredient. And the final ingredient is routing. And this is kind of the $1 million, the big invention, or the thing that really makes the internet work, is that when I send a packet to the Wi-Fi access point here, that thing knows how to route it to the next hop. And that address and the way routing works allows that to work. And what gets quite interesting when you're routing money is you need to know how much that's going to cost. So when I send money to a connector and he's going to send money on for me, I need to know how much of that is he going to take for himself. If I give him 100, is he going to pay out 99? If I give him $10, how many rands is he going to deliver? And what the routing protocols do is share liquidity curves amongst all the connectors to allow them to calculate that stuff. So that's Interledger. I apologize for dumping a pretty technical bunch of stuff on you so soon after lunch. But I'd encourage you to go and check it out, play around with it. It is a completely kind of neutral project in terms of connection to Ripple. You know, the community group that works on it at W3C is co-chaired by myself and a guy called Dimitri de Jong from BigChainDB. As I said, lots of participants. But this site, one of the guys in Lux recently put up, and I'm really excited about this site and what it reflects. This is a simple script tracking a bunch of people who are all running reference implementations of Interledger. They've got a little bit of code that they're running on a server, and that code runs a little website and a bunch of services. They can log in there and they can peer with other people. And they can establish trust lines with them, either through a ledger or just directly, just a bilateral trust line. And they can say, cool, I trust you for 100 Rand. We'll settle, you know, via cash, or I'll send you an EFT, but I'm going to give you 100 Rand credit. And I'm going to give this guy over here $10 credit. And these people are all peering with each other. And so we're establishing slowly a little peer-to-peer network of people who have got credit with one another or settlement arrangements with one another. And now people on that network can actually pay each other. It's working today. It's buggy, but it's working. I would encourage you not to put too much money into this just yet. But it is possible today for you to go and start up a node, peer with a few people, and actually see money moving around on the internet in seconds with nobody involved. No cryptocurrency, no ledgers, nothing. It's purely peers of trust. Now, obviously, that's going to have to evolve over time so that those peers have a ledger in between them that protects them from one another and enforces things like the conditional payments. But right now, it's possible to do this just based on I'm peering with someone I know and I trust them and I give them I don't let them run away with all of my money. So have a look at Connectorland. It'll link you to the rest of the project. Download the code, run it. It's a really interesting project. In terms of integration, something that we are pushing for, and we're desperate for volunteers or anyone interested in other ledgers to contribute to, is integrating the Interledger project into other ledgers. So some of my colleagues in Europe presented at Bitcoin Amsterdam yesterday, a payment through Ripple and Lightning on the testnet using Interledger. And that's all basically because guys have written plugins for those networks. So there's a Ripple payment channels plugin, there's a Lightning plugin, which is semi-working. We're working on an Ethereum plugin, but any of these would be welcome. So open source community, open community, anyone who's interested, come along. We'd really appreciate input into this. And just to make a point here on the kind of collaborative effort that's happening here, we actively get involved in the issue lists and the discussions of other projects. The other day, Stefan logged an issue on the Raiden issue list to suggest that they standardize on a different hashing algorithm, just so that everybody is interoperable. They use SHA-3, everyone else is using SHA-256. Ethereum, go figure. So that's the technical stuff aside. Now I'm going to do some stargazing, and you're welcome to call me part of the lunatic fringe at the end of that. But back to our friend Vint Cerf and the internet, and as opposed to taking purely our inspiration, we're looking at how the internet has evolved since it was at the stage that we are today with the Interledger to today, and what that might mean for payments. So this is our prediction, and these are our thoughts. Visa and MasterCard, any other payment network that you look at today, predominantly they compete on reach. Visa is everywhere you want to be, MasterCard for everything else, there's MasterCard. So the competitive advantage that payment networks have today, and you'll hear it in the cryptocurrency community as well, it's all about reach, right? What can you do with my network? How far can you go? That used to be the case for information networks as well. This is a nice old CompuServe ad. The biggest, the most members, the most services. Right? Information networks also used to compete on reach. It's a little before my time, but apparently AOL used to distribute CDs and magazines just to try and get people to sign up to the network. You know, free AOL subscription, etc., etc. Internetworking completely changed that. Reach is a commodity in an internetworked world. So think about that for payments as well, and I'm going to drill into what that means. Look at a South African internet service provider ad today. Why choose us? Service, not reach. Imagine AfriHost advertised, connect to us and you get access to the whole internet. We give you, you can email anybody. Same for Web Africa. It's all about speed. Fastest. RSA Web. Fastest. Reach is no longer important in an internetwork world. So what did that do to business models and so on around data? There's the costs of moving data over time as soon as the internet took off. So what is that going to do for payments? It's interesting to think about these things and consider when you start taking out some of those fixed costs, how many business models suddenly become viable that aren't viable today. So when reach is no longer a competitive advantage and everybody's competing to be faster and cheaper, what is that going to do to the overall cost of moving value around? So did the internet just give us cost savings? No. This is YouTube without the internet. There's a whole box of movies about cats in boxes. You can order them online. They get sent in the post. So obviously it didn't, right? The change that the internet brought around was a complete change in business models, whole new business models. All of those companies there wouldn't exist without the internet. These are like Goliaths of industry today, right? These are not Mickey Mouse startups. These are some of the biggest companies in the world, built entirely on the back of the internetworking of information networks. But protocols today are suffering from the barter problem. The whole internet economy is not complete yet. We've only got one half of that exchange, right? Two people, two machines, two whatever, they can exchange data freely. But generally, you're exchanging data for something. You want money in return, or you want something. And so we're stuck in this barter problem where we have to find that other thing to exchange, right? We're looking for that double coincidence. So I'll give you a moment to read the quote. But bartering is incredibly inefficient. And so, online, we have a whole bunch of hacks to solve that today. We have aggregation, where we give up huge amounts of the value in a transaction to somebody in the middle who's prepared to be an aggregator. We give away our own personal data as payment instead of money. So we barter access to services for data. Or we bundling other things with the services we want. I want to read the New York Times. Can you find any content on there? Oh, it starts over there. So all of these business models, online publishing, music distribution, they're all stuck because it's so inefficient to move money. And users are starting to opt out. Users are starting to change the way they do things. So you know, we started with, I'll buy a song one at a time online, to I'll buy a subscription. But that just moved from one hack to the other. That just moved to bundling. Now I have to buy all the songs at once. I can't just directly communicate with the artists I'm interested in, get their songs and only support them. What we really want, and what the internet gives us, is a complete peer-to-peer model for commerce. Everything is peer-to-peer. And that doesn't just mean information, it now means money as well. So if you can create this hyper-liquid world where money moves as freely as information, you enable this. And it's pretty exciting to think about what that can mean. I mean, we've known this for a long time. I think for Zam, there was a great history lesson on money. Money solves the barter problem. You're no longer, trading a cow for a cat and saying, "Promise you, my cat is worth one cow." Money quantifies things, but it's very difficult to use money in the digital world today. What's also interesting to consider is that today, humans pay for goods and services. But in the future, there's going to be machines paying each other for goods and services. Payments, our prediction at Ripple, and certainly what we're focusing on, is low-value payments. Today, most payment systems are a relic of old architectures where low value is all done and batched together, and then the real movement of money is settled in a big bunch later on. That's not the future, right? The future is high volume, low value payments, but not 10 times more volume, billions of times more volume. There's really interesting use cases for blockchain, and I think today we've been quite financial services focused, and I'm hoping we'll dive into some of those, like identity and so on down the line. But if you're thinking purely about payments, and you're thinking about things like trade finance and what banks do today, you're thinking way too small. Imagine all of those taxis are just communicating and exchanging money with each other. The taxi at the back is in a real hurry. He's prepared to pay all 3 taxis in front of him to move aside so he can get past. And they all know that because they all have the AI built into their taxi monitoring system to know that it's best for all of them, for the taxi industry as a whole, if the guy at the back gets through and drops his person off on time, because it's a great experience using a taxi. And so for a small fee, they'll just get a little indicator, hey, change lanes, the guy streams past. So think of all of these, another conversion, that's 3 out of 3. Think of all these use cases that suddenly become really interesting, or that are going to impact the volume of payments that are being demanded by the economies and the business models of tomorrow. They're really exciting and I think very different to how we experience the internet and digitalization today. One thing to think about is that maybe some of these big disruptors of the internet age are ripe to be disrupted themselves. Spotify was an example I used before. They're a bundler, they're an aggregator. When artists are able to seamlessly send you money and get payment directly, what is Spotify going to be useful for? Now I'll get into the controversial stuff. So I've got 2 slides left, but I wanted to give a shout out to a group of guys at Ripple who are really awesome and have been there since the very early days. And I think we've got generally a bad rap. Ripple has, I kind of think of Ripple as a company in sort of three parts. There's commercial Ripple. There's the Ripple that you will see in the news. There's the company that pays my salary. That company is focused on cross-border payments, selling solutions to banks, really innovative, really cool stuff. There's the Interledger piece. So there's our research team who does a lot of work in that. There's the fact that we use Interledger as an underpinning technology for the commercial solutions we sell. But the third piece, and a piece that I think a lot of people in the cryptocurrency community and the blockchain community have forgotten about, is Ripple's distributed ledger. Ripple's distributed ledger is awesome. It's unfortunate that I think over the last year or two that it's been hidden a little bit behind Ripple's commercial operations. It's open source. It's available for anyone to use. There is a company in South Africa pitching a solution to banks that uses Ripple's open source technology with no involvement from Ripple. They are here today, and I won't tell you who they are. See if you can guess. So I would encourage you to look at Ripple, RippleD, at the Ripple distributed ledger. It's not Bitcoin. It outperforms Bitcoin in many categories, but it doesn't do the same stuff as Bitcoin. It is first and foremost, it's an amazing payments platform. That is what it was built for. That's what the original concept was for it, and that's what it does, and it does it really, really well. It's well supported by a company that has stewarded it for 5 years with no issues. Been running in production with real value on it for a very long time as the second biggest cryptocurrency in the world by market cap. A fair distance behind Bitcoin, admittedly, but pretty significant until Ether grew as it did. And personally, I think the only reason that Ripple isn't up there with Ether and Bitcoin is that Ripple as a company hasn't been able to put the focus into it that I think we would have liked to. And the community didn't take hold of it and do something with it as we kind of hoped they would. So if anyone is interested in doing projects on blockchain, wants to look at some really, really awesome blockchain technology, I would encourage you to look at this. Look at Ripple's distributed ledger. If your use case is payments, it is awesome. It is a seriously, seriously impressive piece of technology. Now, I think it's fairly obvious then why, as Ripple, we're so invested in Interledger protocol. It's an open protocol, right? Nobody gains anything by an open protocol itself or by open source software itself. You win in the industry, or you succeed by the fact that you give something to the industry or the community that's open and useful because you trust your ability to execute on top of it. And that's really what Ripple as a company is doing with its commercial solutions. But we genuinely believe that XRP and Ripple's distributed ledger technology will make it, will become more influential globally with interoperability. Because when everything is interoperable, you're no longer competing on reach, you're competing on how good is your network. And personally, I absolutely believe this. Ripple's is up there. And that is all I have to say, and I've got 5 minutes for questions. Oh.
Excellent, Adrian. Fantastic. Thank you very much. Questions starting over there. Mike, please.
Hi, Adrian. I have a training company that teaches people how to trade, and we've been taking note over the last few years what each currency does, and Ripple especially has made some ripples, but since November last year, it looks like the Zcash, those guys who are trading know what I'm talking about.
Yeah.
Can you explain to us what has happened that Ripple been running between 1,000 and 10,000 Satoshis, now sit at 400? Just from a
Sure, I can try.
A trader's perspective.
I can try. So I think as a US company, I probably have to make all sorts of disclaimers here about forward-looking statements and things like that. But personal opinion, it's been very difficult to push XRP at the same time as focusing on Ripple's commercial interest, which is selling cross-border solutions to banks. So XRP is by no means something we're not interested in anymore. I mean, Ripple holds 60% of the XRP in circulation. It was what got us to where we are today. It funded the company. And it's certainly, if you hold 60% of a global asset, you have a vested interest in that thing being successful in the long term. So XRP is still a very big part of Ripple's strategy. The problem is it's part of a longer term strategy. And I think what's been a challenge is to keep the market interested as we play that strategy out. So for the big banks, for the guys who are forming like our global payment steering group and running Ripple solutions and setting up this cross-border interbank payment settlement network, they don't want to touch virtual currency. They want to use Interledger protocol to move money directly between each other. And so XRP's real value is going to come when that filters down into corridors where currencies are a little bit more obscure. So my ideal would be that XRP becomes the bridge currency for anything other than dollars and euros and pounds and yen. That instead of, as a bank, instead of me needing to hold nostros in all these different countries, I hold XRP and I can trade immediately into those countries for those currencies. And that's the Ripple vision for XRP, but that's very difficult to execute on until we've got the Ripple solution in place at a significant number of banks. So yeah, it's a difficult one to answer. Feel free.
So you're saying you're basically moving out of the banking finance sector into just cryptocurrencies and peer-to-peer transactions?
Who? When you say
Ripple
you? No, Ripple is absolutely focused on banks, interbank payment settlement, cross-border payments. Our stated company mission is make cross-border payments seamless for banks and their users. Part of a bigger vision of Internet of Value. That is Ripple. Interledger protocol, the work we're doing in the sort of research side, is more generic than that. It's payments. We've focused specifically in Interledger on micropayments and sort of really low value payments because we want people to play with this stuff. We want them to use it. We want to start establishing a network of people using the protocol. And it's dangerous to ask people to move big amounts of money, right? And so it's on that side, there's a big focus on small values, cryptocurrencies, because you can easily, I can go and integrate, I can go and write a ledger adapter for Ethereum tomorrow. I can't go to a bank and say, hey, can I integrate into your core system so that I can Interledger enable it just to do some testing? So permissionless nature of cryptocurrency is great for what we're doing on the research side. XRP is still part of the vision for Ripple as a company for cross-border payments as a reserve currency, a global sort of reserve currency. But it's difficult to execute on that strategy until the core customers, the big banks running the ILP-based Ripple solutions are in place, because those guys are still, ultimately today, the value still moves traditionally through those big banks, and they're the guys holding lots of value. But there are still these other corridors that are neglected, and we need to get there. But I would kind of think of it as going as sort of a top-down approach. We need to start at the top and filter our way down. That is not to say, and this was my point in the last few slides, that anyone else can take the technology and do something with it. And that, for me personally, I joined Ripple pre-ILP, before ILP was getting going, I had spent a year looking at Ripple just as technology, amazing technology. And so for me, it would be fantastic if someone outside of Ripple said, cool, we want to use this technology to build a financial inclusion-based solution or whatever. That would be great. Ripple is still going to back the currency, is still going to do everything it can to make sure XRP is successful. There's an XRP incentive program, in fact. So if market makers are prepared to provide liquidity for XRP, Ripple will incentivize them with more XRP, just to try and create liquidity in these minor currencies and these different markets, really just to set up that market for international payments.
Cool. Adrian, thank you very much. Can I ask you one question? Can I have a stick? Can I have a sticker, please?
You can. They're outside. I'm going to put them on the table outside. They're actually in my bag there.
Cool. Thank you very much. Great. Thank you.